Hello guys, so I just realized recently that I have somehow acquired accidentally 1,000 subscribers, even though I never really meant to use my YouTube channel for anything other than teaching my classes. So, to celebrate, I decided to do a new video, which is going to be for one of my classes, but it's kind of for fun. Somebody at work gave me this fidget spinner that has three circles. As you can see, this is just normal fidget spinner, and each circle actually has three inner circles with flashing red, green, and blue lights. And I've been playing with this thing and staring at it, and it's kind of hypnotic. And as always, when I look at anything, I imagine what type of information it takes to represent it. So when I thought about how easy it would be to do a little fidget spinner video game, I thought I would use it as an example for basically HTML5 canvas and JavaScript for all you guys out there who want to be able to learn how to make a little video game in a day. So I did this I pretty much put it together in one night. I spent like the next day just obsessing over little details. The code is still pretty crap, but um, I put a couple hours into making the code pretty, but not too pretty. So let's get into it. So first of all, how it behaves, I'll just show you the gist. I have 5 little scroll bars over here, which are, well, I'll just show you the HTML first. So as you can see, the page has 5 inputs. They're all range inputs, which are HTML5 controls. And I use these to control the outer speed, the inner speed, the padding, the radius, and the style. So I'll leave the style one alone for now, but oops, I don't want to show you that yet. The outer speed is basically this guy right here. So you'll notice that as I increase the speed of the left slide, it starts spinning faster and faster and faster. The higher I go, you start to get some cool visual effects like you do with a helicopter blade. And this middle guy, actually I'm going to crank the style up to 2. Every time I have four style settings, and the higher it goes, the little more it shows. So the second bar is controlling the circles on the inside of the fidgets. So you can do those both at the same time. And then this guy here, I don't even remember what it does. Oh yeah, he pulls him inside, so I can spin around and spin those around and go in and out at the same time. And then this last guy here, I think, controls how big they are. It just makes them bigger. Ooh. Okay, so this before I show you the final product, I'm going to go up one more time and do that and show you the colors. So let's see what this thing can look like once I make it a little bigger. Pull them in a little bit. Just nail the speed on that. You can start making like cool kaleidoscopic algorithms. This is actually for my algorithms class, so I want them to really think about all the different mathematics that goes on in here in order to form the different kaleidoscopic algorithms. So you can change the variables and get different little effects here. I like it when you pull them all together and you kind of get this pulsating color. All the colors start mixing together. It's really nice. It doesn't look as good as the real thing, but it's pretty cool for something that I put together in a couple hours. So before I show you the kind of the finished product, I'm just going to reset that and dive into the code to show you how I did this. It's actually really easy. Like I said, you can make your own video game in pretty short order. So let's look into the code. I started by, you know what? I just realized that I have not done a video yet on HTML5 Canvas that is very detailed. I have one out there, I think, for HTML5 Canvas that's really basic. That just shows you how to do the really basic stuff. So I apologize if there's a little bit of a gap there. Maybe I'll do another video pretty soon that kind of bridges that gap and goes from the ground up. But I'll try to bridge it a little bit. In this UIKit.js, I tried to give myself a very basic framework for drawing circles because this whole program is about drawing circles. So what I did was this is basic canvas stuff. So if you don't understand HTML canvas in and of itself, I mean, the basics are you create a canvas element, and then you grab it and you get the context, and you start modifying the context. And it's basically like a Flash movie embedded in your browser. So this is vector graphics as opposed to raster graphics. Raster graphics would be like bitmaps or JPEG images, sprites, and vector graphics are defining graphics mathematically, which is what you do in Flash and HTML5 canvas. This is a little movie. It's basically a little, well, I guess it's a kind of a, yeah, I mean, they call it a canvas for paint, like when you're painting on something, they call that a painting canvas. So it's like this little canvas that you can paint on. So with my UI kit here, I was trying to just give myself some basic tools for painting. So this is a function that I wrote for being able to clear the context. Notice most of these things are working with the context or this UI object that has the canvas on it. So the canvas is the element itself, and the context is telling the canvas, get me the context of the two-dimensional vector graphic space. And then I declare myself a couple of mathematical variables here. Before I begin, I guess let me just quickly run down the mathematics you need to understand to be able to draw these circles. All you really need to understand is this very bottom line here. So I was thinking to myself, you know, like obviously I can do the geometry of a circle, but I'm not really that great at trigonometry. So I thought to myself, well, if I have a circle and I want another circle to change its XY coordinates of the center point, which is basically all you're doing in this program, is you're taking one circle that has a radius and a center point, and you can easily draw another circle, let's say 100 pixels to the right of that. You would just take the XY coordinates of that circle center point, and then add 100 to the X coordinate, and then draw another circle. So that'd be super easy. But the question is, how do you move those XY coordinates of the second circle in a perfect orbit in a circle around that other circle? I'm doing like hand motions while I'm talking that you can't see. So the answer is this formula right here. So I think A and B, as it says here, is the original circle. So A comma B would be the XY coordinates of the original circle. So the original circle's X coordinate plus, let's see, what is R? The position of the initial point is theta radians across the circle from A plus R comma B. So yeah, basically a radian represents a number between, I think it's here, let me look in my math here, it's a number between 0 and 2 times pi. So 2 times pi is the maximum value of a radian, and 0 is the minimum value of a radian. And that range between 0 and 2 times pi represents the position on the perimeter of a circle. So if you imagine 0 being at a place on the circle, and then you added basically like half of this, so math times pi, you would be on the opposite side of the circle. So as you increase the radian from 0 to the max, you're basically traversing the length of the perimeter. So it's important to understand radians because you have to understand that going from 0 to the max radian is going the distance all the way around the circle one time. So that's very important to understand that max radian is the distance around the circle. So if you want to do one orbit, you have to increase the radian by 2 times math.pi. So if you read this, and you'll see my code. My code is actually much easier to read than this, but you can translate this into what you see in a second. So this clears the context. This draws a simple circle. So this guy says, you're giving me a model and some colors. Well, I don't know what those are, but they're JavaScript objects. So they have values inside. And you'll see when I open up the colors object and the models object what those have inside of them. But I'm basically saying I'm going to give you some data and some more data, and I want you to draw a circle with the XY coordinate, the radius, and some colors. So I'm going to skip down to draw a circle down here, and I'm going to kind of skip over this one for now. And draw a circle basically says I want to actually do my canvas work to draw a circle. So this stuff here is the guts of how you draw a real circle, how you draw a circle with an outline and a fill in HTML canvas, all based on the context. So you set these properties, how thick you want the outline to be, how thick you want the shadow to be, and you give them both a color, the shadow and the outline, and then you start drawing. and you give it an XY coordinate, a radius, and here is the basically the guy that governs um, kind of the way that it strokes the perimeter of the circle by saying 0 and max radian. So you can pretty much just copy and paste this code and always use it for for drawing circles. And I have this stuff on GitHub, I think, so I'm not going to open it. It's on my GitHub in my algorithms repository, github.com/DonnieSantos, which I'll put in the link to the video. Anyway, so this is how you draw a normal circle, and that's very, very easy. So anybody that's done HTML Canvas can do this. So the interesting part is draw the orbiting circle, and this is basically the core of what you need to do to make this particular video game or this particular Flash movie or Canvas movie. So based on an origin and a destination, so the origin would be the middle circle and the destination would be the circle that I'm drawing in relation to that and some colors. Here is that same equation that well, it's not an equation. Here's the same formula, the trigonometric formula that you saw before. You take the x-coordinate of the original circle and you add however much padding you want, and you multiply that by the cosine of the radian of the destination. And so if you think about this is the important part right here, right? You're trying to say, and if you look at both of these, right, the cosine is for the x-coordinate, the sine is for the y-coordinate. You're trying to come up with the x-y coordinate of the new circle. And you're going to do it over and over and over again. And every time you come up with a new xy coordinate, it's going to orbit, a little bit more around in a perfect circle. So if you think about it, each time the destination radian is increasing, which should make perfect sense to you if you understand what I just said, because since the radian describes how far along the perimeter you are, by using that value, we can easily come up with the xy coordinates by interjecting the cosine and the sine around the radian. So it's actually pretty simple, even for somebody who sucks at math like me. So based on just computing new xy coordinates, I can move that other circle a little bit further around the perimeter, and that's how I get that circular motion around the inner circle. And when I'll use this in two different ways, and you'll see how I get both the outer orbiting fidget spinner circles and the inner circles. So that's pretty much my whole UI kit. This thing right here is pretty much, you always need to have something like this, which gives you a handle on the frame. And I covered that in my basic HTML5 Canvas video. And this again, pretty much copy and paste every time you're making HTML Canvas. Okay, so this is what I use to draw circles. So I can draw any circle I want, and I can draw a circle orbiting around that circle with this. So that's kind of the hard part. Then I get into the not hard but tedious part. So I create some models. So this is just data. This is just data about my circles. So I basically create a new, this is the equivalent of a namespace by having an object that controls all your methods and models and variables and things. So I have this model namespace, and I say my radius is 60. That's how big the fidget circles are. The padding starts at 140. This is the number that's going to get controlled by that bar. I think it's the third vertical range draw bar. So these are just models. They're just objects that I create to keep track of where everything is. So the centerpiece is the unmoving fidget in the middle. So it's got a radius, a padding, an x, and a y. These are the three big fidgets. So these three radians space them out perfectly in thirds around the middle circle. And the padding is how far from the inner circle they are. So this stuff is just basic geometry. And the lights are the little circles. So you can see I only have one array of 3 light models. So I'm actually going to reuse this 3 times and kind of transform the values according to what I'm drawing the lights in relation to. So you'll see that I only need 3 models even though I'm drawing 9 lights. So back to the screen to show you. These guys here, whoa, these guys here are the lights, the red, green, and blue. And those are, even though I only have one model for the red light, but I'm reusing it 3 times, so I'll show you that in a minute. And then I have a model for speed. So I want to be able to easily change the inner speed and the outer speed. So all these are just data structures that I'm using to store values easily, so that I don't have to have a million JavaScript variables, because using like a JSON format to store data like this is much more intuitive. It's just an object. It's just a data model. And everything you do these days is with JSON and JSON models, and this is just keeps it consistent with most software development. So if anybody else looks at this, they'll be like, oh, it's just a model. And then the real tedious part is this colors one. So this is probably some crap code that I threw together at the last minute just to make it work. You'll notice I was really in a hurry kind of to just get different color schemes. The color schemes are the differences between these. So as I change the color scheme, that's changing the look and feel of the whole thing. And there's one more color scheme that I haven't showed you yet. It's the good one. So you'll notice it says "is music on?" You're like, "What music?" There's music. I just haven't shown you yet. So I start off by setting the color scheme to 0, because there's 4 color schemes, and I say the music is only on if you go to the 4th color scheme. And here I'm just setting up more data. So what do? I use a little object-oriented JavaScript down here to create an alpha level that has 3 properties. And I can create circles. Again, this is just object-oriented JavaScript where I can create instances of a circle, right? So if I create an instance of a circle, I can say, here's the RGB value of the outline, here's the width of the outline, here's the width of the shadow of the outline, here's the RGB of the fill, here's the alpha value of the outline, and here's the alpha value of the fill. And notice I'm referring to my models to get, I'm referring to my alpha models to get the values for the fill. So all the models are kind of like referencing each other in a nice data structure oriented way. So I'm not doing everything manually or hard coded or heavy handed. I am coding this with a little bit of reusability in mind. Like I said, the colors.js is not like my master work or anything, but it got the job done without being too ugly. So basically I have this alpha level instantiable class, and I create different alpha levels here. And I haven't shown you what I use alpha levels for, because that's in the 4th style, but I'll show you that in a minute. So basically I create 7 circles, right? So the center fidget, the 3 fidgets, and then the 3 lights. And like I said, I reuse those lights. So down here, the alpha levels, I have a little algorithm here to say I want you to keep increasing until you hit 1, and then start decreasing, and keep decreasing until you hit 0.1, and then start increasing again. So it kind of goes up and then down and then up and then down. It fluctuates between 0 and 1 at a rate of whatever I tell it. You're going to see, you know what, I'm just going to bite the bullet and show you now. So the alpha levels is for the 4th style, and block your ears because this was going to get really loud. Okay, don't say I didn't warn you. Sorry about that. So the long story short of that is that the alpha levels are for kind of that pulsating glowing of the outer rim. So one more time, I'm actually going to turn this on and the music's going to blast for a second, but just without it moving, just pay attention to how the inner lights are pulsating much faster than the outer lights. So the reason I showed you that is because I have two different speeds of this fluctuation, and that's why the change rate is different sometimes. That's why I have a parameterized change rate here. All right, I think that was really, really loud compared to the volume of my voice. Sorry about that. Anyway, so down here, I can tell you that I have this function get alpha level, and based on whether I say fast or slow, it's going to instantiate an alpha level object with a 1.0 alpha, initial alpha, and this is the change rate. So notice this change rate for fast, it increases quickly. So the inner lights, they're basically blinking so fast, and the outer lights are kind of pulsating real slow. I wanted to give that distinction so it would kind of look more confusing and chaotic, kind of like a rave party. So now we get down to the four schemes, and I went through a couple of different versions of this. This is, it's not gonna be pretty. Anytime you're dealing with, like four different color schemes and skinning things, it can get ugly. But this was not bad for what I did. So basically, you remember those 7 circles I was talking about at the top, the center circle, the 3 fidgets, and the 3 lights. For each scheme, I just instantiate a circle object, which, real quick, once again, circle object um, has the fidgets and the lights, and it can update the alpha values. So by doing it in an object-oriented way like this, I can call this function once. I can say, hey, update alpha values. And for all 7 circles, it's going to iterate through there and update the alpha levels. So when I want to do that pulsing rave party thing, I just have to call this function once, and it will proceed with the changing of the alpha values. So by mixing object-oriented programming with the data modeling, I've kind of provided a little bit of reuse. I know I'm not going into like rigorous, gory detail here because, I kind of just did this for fun, and it would probably take like an hour if I went through every line of code and explained it in super detail. And it looks like I've got 7 more minutes if I want to finish this in a half hour. So let's finish this thing up. So you can see all I had to do is copy and paste my scheme 4 times, and for this last one, I said nothing on the inner circle. The 3 big fidgets pulsate slowly, and the lights pulsate really fast, both the outline and the fill. And then I change the colors. So all of these numbers here, these are what control the RGB colors of the circles. And that's pretty much it. So the only thing I really haven't shown you is how I draw the circles and how I get 9 lights instead of 3, because it's pretty much all the colors are all coming from here, and the model data is all coming from these guys here. So all I really need to do is draw this data, draw the circles with the orbiting circles using this data and linking in these colors. So it all comes together here finally in my scripts.js, which is a very small file. There's only 60 lines of code in this program because I've given myself the models and the colors and the UI kit as a foundation. So that's kind of like the key of my design here. If I'm going to say that I had a design, like I said, I did this in one night, but my goal was to make my main program very short. So as you can see, 60 lines of code is very easy to read and understand. So I will start by showing you the document ready. So this is what happens when the page loads. So what does it do? It applies the color scheme 0, obviously. So when I reset, the models are reset and it applies the first color scheme. And then it says bind range input. So what does that do? If I scroll up a little bit, bind range inputs is the big guy that grabs those elements in the HTML. Remember these guys right here, the ranges. So it grabs every one of these inputs and binds a function to them. So for the outer speed, it grabs the click event and it says I want to treat you like a percentage. So take whatever was the value between 0 and 100, divide it by 100, so I get a percentage. I'm going to multiply that by one of the values in my models. In this case, model, speed, outer, max. So back in my models, model, speed, outer, max. See, this is the nice thing about having, kind of a JSON object type of data structure. You can just easily modify and get at anything in a very semantic kind of way. And JSON makes everything easier to work with. Like JavaScript is really awesome because you can have something be both an object and a kind of a JSON construct. It makes it very, very flexible and easy to work with. So I could have done this so many different ways. I could probably do this so much better if I had more time. So basically, I took my model, which everything is based on. So you're going to see me later use model speed outer value. I'm going to actually use that to move the coordinates. And I am saying I want to increase the speed by the percentage times the max. So if the percentage is 50%, 50% of the max speed. So halfway up the scroll bar is 50% speed. Makes sense. I do the same thing for all these. I have percentages, and so I'm incrementing the outer speed, the inner speed, the padding. The only one that even has a bunch of code is this one. This is the radius. And the reason this one is just code is because I had to change the radius of all three fidgets. Then I had to change the radius of all three lights, and then I had to change the padding of all three lights. Because when the fidgets get bigger, it kind of changes some of the math. So again, this is just simple geometry, but I had to change some values when the fidgets got bigger. I probably didn't even need to do this because it looks the best when the fidgets are normal size, I think. Anywho, this is kind of getting to the end here. So the last bar obviously changes the value of the color scheme. That's easy. It's just a number between 0 and 3. And now, the end. This, believe it or not, this is the guts of the program right here. This is the core of the logic of what is going on here. Obviously, the animate function is just a clear render over and over again repeating. So this is really the program in and of itself. If you just look at the render method, you can figure out how the whole thing is working by going to the inner functions. So it's obviously two loops. The outer loop says go once for each fidget. Well, with the exception of the middle fidget, so it just draws that thing based on, it just draws a circle based on the center fidget model. That's super easy. So here's the logic for how the whole thing works. I just go through my models. There's 3 fidgets in the models, and so I'm going to go through the I loop 3 times. And here's the math. So I increase the radian, which remember is inside these models. So if I look at my models, fidgets, there's my radian, the first radian, second radian, third radian. So by increasing those, I'm moving the fidgets basically around the center model. So by increasing that line of code right there alone is what's moving the, well, not alone. That line is what's computing the value necessary to move the circle. So if I increase the padding, I'm doing this one here. But that's not really that hard. That's just, I'm going to focus on the radian one because it's a little harder. So what happens is, since the model now has an updated radian and updated padding, so these values here will be updated for all 3 circles, all 3 fidgets. What happens is that remember this function, draw orbiting circle, this is the guy that does the trigonometry. And it needs to know the origin circle, the destination circle, and the color scheme. So basically these 2 models right here, comparing where the centerpiece is and where the new destination circle is how it calculates the new x-coordinate. So this radian here changes the fidget model. The fidget model is now updated. It's the target circle. So when you go into draw orbiting circle here, you're going to get new XY coordinates because you change the radian. You change the destination radian. It's that simple. The destination radian changes, the destination padding changes, the XY coordinates change, you're animating things. So that's really it. It's really, really easy, actually. The only other thing that I did was I took it one step further and I said, now I want you to iterate through the lights. But since this for loop is inside of the I loop, it's not going to happen 3 times. It's going to happen 9 times. So J012 is going to happen at each iteration of I. So it's going to use, obviously, instead of using the centerpiece, the center fidget as the origin and the fidget as the destination, it's going to use the fidget as the origin and the light model as the destination. And that's how I get the little circles orbiting in relation to the fidgets. And that's it. So with some very simple geometry, so let's think of all the things we're combining here in order to be able to do this. Very basic understanding of HTML5 canvas, drawing circles, vector graphics. So very basic there. Understanding HTML, CSS, and JavaScript. Let's see, a very, very, very small amount of geometry and trigonometry. Mostly just object-oriented JavaScript, a little bit of JSON, some jQuery, but mostly all we're doing here is, excuse me, combining HTML, CSS, and JavaScript with the vector graphics foundation of HTML5 canvas. So all in all, I mean, combining those things with a little bit of knowledge of mathematics, you can be in business kind of doing something like this for, in a couple of hours. You can start drawing some vector graphics. And, you can combine raster graphics and vector graphics into creating a game that looks like, if you have the sprites, you could make like an old school Final Fantasy game or something to that effect. So it's been like 32 minutes. That's kind of a long time to talk about something like this. But just once more, to show you what's going on. There's the circles. I'll pump this up to the whole shebang, and you can see now, hopefully, with the knowledge of what's going on behind the scenes, the outer I loop is changing the coordinates in the models that cause the XY coordinates, the padding, well, actually, just the XY coordinates of the outer circles to change. So the padding and the radians cause the coordinates of the outer circles to change. And then in the J loop, I'm changing the radians and the padding of the inner circles. So again, all we're doing is computing XY coordinates. Because to draw a circle, all you need is the XY coordinates and the radius. That's it. That's it. So all you need to do is to be able to constantly figure out what the right XY coordinates are. That part's very easy. The hardest part actually was the colors, because it was really tedious to try to think of a way to store all of that information. Like I said, it was kind of this was the kind of like the best I could do on like a short notice. I was like, well, I'll create a circle class, and it'll have all an alpha level inside, and then I can just instantiate 7 of them for each color scheme. So I wanted my one color scheme to be pretty small. So sorry for the frantic pace of this. I just knew that I like to talk about graphics and stuff, so I didn't want to get carried away and talk for 3 hours. But the code's on GitHub. I'll put the link right underneath here, and hopefully, if you liked making Flash games or ever wanted to make a 2D video game, you should be able to do it pretty easily now. I mean, you don't even need to have like these scroll bars on the outside. Using click events and knowledge of the XY coordinates of the mouse, you can easily, just as easily interact with this. Originally, I was going to have it so that, to change things, I actually clicked on the movie itself, but, whatever, you can do it however way you want. If I have any better ideas for other cool video game types of things, I'll post them. But I'm teaching 4 classes this semester, and most importantly, I'm teaching an algorithms class. So I have some ideas of some cool new algorithm-related things to code and show you guys. So I'll be making new videos soon. I know I was gone for a while, because I was so busy at work doing mobile apps. But like I said, I'm back teaching really heavily now. So I will hopefully be posting another video soon, and I hope this was helpful. I've always thought HTML5 Canvas. Well, actually, I always loved Flash programming. To be completely honest, I loved Flash. I know a lot of people didn't like it, but now I try to do the same types of things with HTML5 Canvas. And with that, have a good day.